Welcome to Math Mini Lessons. We're going to do some geometry today, and this is super visual, so I love this. We're going to identify lines, angles, and polygons. So look to see how our goal is really to be able to identify perpendicular and parallel lines, like tell the difference and know when we see it. So when we see it, we recognize it. And being able to recognize lines, rays, and angles, as well as different types of angles if they're acute, obtuse, or right. So let's jump right in. First things first, we got to know what these words actually look like and get some examples. So we have 4 words here: point, ray, line, and line segment. And starting off with a point is just a spot on a plane, like a particular point. And usually they're labeled. They might have either a letter or just a point somewhere. So that's all a point is. And I literally would just call this one like point A. That's the example I have here. It's just a point. Or you might see like a line and just points on them, but here these are the points. A ray is a point and then a line that goes on forever. So you would literally see like a starting point and then something like this, like a line that goes forever. So kind of like start, run, but that's a ray. And if it has, and it might have some letters in it, it may have something like this, then I might call this from A to B. This is ray AB. So notice my arrow goes from the starting to the next point. A line goes on and on in both directions. So, and I'll have 2 arrows at the ends to show it goes on and on forever. So even if I put some points there, let's say I have C and D, I might call this line CD. And I'll draw it like this, so a line and a little arrow on top. And then a line segment is like a part of a line. So it has 2 endpoints. So it definitely ends boom and boom in one spot. Okay, so there's my line. And again, I use the 2 points and I just draw a line over it. So these are our first 4 vocab words: point, ray, line, and line segment. Hit pause and jot this down. Now these next 3 are super important. They have to do with the words we're looking for today: intersecting lines, perpendicular lines, and parallel lines. So now we have multiple lines. So let's say I have 2 lines and they connect, so they touch somewhere. These are intersecting lines because I have 2 lines and somewhere they cross over or they meet each other. So that's all it means. Sometimes a line might, I'll try and show it down here. Like I might have a line here, it's going on and on forever. Another line here. These 2 lines are still intersecting. Even if it doesn't go through the other line, these are still intersecting lines. The next one is a perpendicular line. And these are lines that cross, but they make a perfect right angle, a perfect 90-degree, like the corner of your paper, angle. So it might be like here's a line and it's going straight in one direction, and this one goes straight down the other way, like an upside down T. Sometimes it's how I look at them, and they make perfect 90-degree angles. So that's what makes these perpendicular. So 2 lines, they cross, like one's going up, down, and the other one's going in the other part, but they definitely make these right angles. The reason I'm kind of stressing that is because I can have a line that goes this way and a line here, and again it makes like that, it kind of looks like that T where I can have that perfect little angle. So these are perpendicular lines. So that's how you spot them, with the right angle. Parallel lines, parallel, like when I'm parallel parking, are 2 lines that are, no matter what, they are never ever gonna touch. They're always the same distance apart from each other. And this is kind of hard for kids to understand. Like I might have 2 lines like this and they're not touching, but they're not the same distance apart. Like they're far, but here they're far closer. So this is not parallel. Two parallel lines are always the same distance apart. Kind of like these two lines here. They're always the same distance apart. These are parallel lines. Or from this line to this line, these are parallel lines because they're always the same distance apart. So when I draw a set of parallel lines, it's kind of like when I look across the street, that street and my street, they're never going to touch each other. So that's parallel. And these are some of the symbols that you're going to see as you get older. When you're in high school and do geometry, you're going to see these same types of lines. But let's go into angles now. Okay, just like there are different types of lines, there are different types of angles we're going to talk about. And the three different types of angles we have are acute, obtuse, and right. Now we kind of talked about one of them already, so let me just get to scribble. Just for definitions, acute angles are angles that are less than 90 degrees. You may be starting and saying, well, first, what's a degree? Well, a degree is something that's made when two lines intersect. And what a degree is, it's looking at the space between the two lines, and we measure that in math, and we call these degrees. And we use a special tool called a protractor to figure this out. So I am going to, let me just erase this part for a little bit, so I can get another protractor here. So here's my protractor, and it's helping me to measure the degrees. And what that means is, so if I'm starting here at 0, the further away the lines are, the more degrees there are. So you can see the numbers over here, starting from 0, 0, and they go all the way to 180. So if I have a line, and this is one line, and I have a line over here. So the distance from here to here is 10, 20, 30, 40, 50 degrees. Now, the farther away my line goes, the more degrees it is. So acute angles are anything that are less than 90 degrees. So here's 90. Acute angles are anywhere between 0 and 89.999, whatever. So if it goes from 0 to anything less than 90, we call it acute. Now, if it reaches exactly 90, that perfect corner, we call them right angles because they would make that right angle. And any line, like if I have a line that's further out that goes more than 90 degrees, we call it obtuse. So this is more than 90 degrees. Acute is less than 90 degrees, and right angles are exactly 90 degrees. Now, if they go all the way to 180 degrees, then we call that a straight angle. Why? Because 180 degrees would make a straight line. So we're going to practice using the protractor in more videos, but I wanted you to at least see what those angles look like and what they will sound like. All right, let's look at our first practice problem. Which diagram below appears to show a pair of perpendicular lines? So remember, if I'm thinking of perpendicular, I'm already thinking 90 degrees. So every time you think perpendicular, 90 degrees, those perfect right angles. So which one of them shows that? And the answer would be B. B appears to show perfect 90 degree angles, where the two lines cross each other, like perfect crosshairs. The first one, these are just intersecting because they're not 90 degrees. And the last one are not touching at all, so these are parallel. Right? So always the same distance. Hit pause and jot this down into your notes. And your job is to be able to recognize these by sight. You should be able to look at it and see if it's perpendicular or parallel. So let's look at the next one. 4 angles are shown. How many angles are acute? So when I think of acute, we already know less than 90 degrees. So smaller than those perfect angles. So if I had my protractor, or right now I don't need it, a perfect 90-degree angle here would have looked like this. So this one's definitely acute. And this one's super small, so I know this one's acute. That's less than 90. This is a straight angle, that's 180. And this one is definitely wider than 90, so it is obtuse. So I have 2 acute angles. Acute angles, they become really obvious to see if they're super tiny, but when they get to be around 85 degrees, sometimes they get a little bit harder. And here we go. All right, hit pause and jot this down into your notes.